Okay, here's another particle motion question. This one is back to calculator inactive, like most of them are. But this is interesting. This looks kind of like one of our graphs without equations problems. Because they give us this graph instead of giving us functions. This is the graph of the velocity. But remember, with particle motion, most of the time they do give you the velocity function. All right, let's look at the context. Hey, this is fun. It's no longer just particle motion. We're talking about a squirrel. Okay, so look out for things like that. There's a reason why I organize these questions the way that I do, because when you see them together, you start to associate certain question types, and you know exactly what to expect. Okay, in the last few years, there have been a couple of questions that they've put a slightly different context to, and it has really, really thrown people for a loop. They freaked out over the question when they shouldn't have, just because it had kind of a strange context that they weren't expecting. They kind of ignored the fact that, hey, these questions are asking you the same thing as one of them that I'm thinking in particular is a volume of revolution, which we're getting ready to cover. It threw people off just because it was asked a little different way. And then the most recent one, I don't know if you've heard about it, but it's the potato problem. It was just a differential equation, but it wasn't set up exactly the way they were expecting it to, and so it totally threw people for a loop. So anyways, same thing here. Don't be thrown off by the fact that it's a squirrel, and then they give you a graph instead of equations. It's still particle motion. So a squirrel starts at building A at time 0, travels along a straight horizontal wire connected to building B. We're traveling for 18 seconds, minutes, I don't know. So they give us the graph. Okay, at what times in the interval, if any, does the squirrel change direction? Well, change in direction, velocity equals 0, you gotta have a change in sign. So let's circle it on the graph. Okay, 9 and 15. So let's say let me use more correct English here. The squirrel changes direction. At times t equals 9 and t equals 15 because velocity changes signs at those times. Okay, so easy. You get 1 point for the t values, 9 and 15, you get 1 point for your explanation. So easy start here. All right, let's see here. B, at what time in the interval is the squirrel farthest from building A? How far from building A is the squirrel at that time? Okay, so we're looking at velocity. We're talking about how far it is from something. So we're talking about area under the curve. Now, some of you will look at this and you'll say, oh, those are trapezoids. I can calculate the area of a trapezoid. Fine, if you do. If you want to look at it as triangles and rectangles, guess what? That's where the area of a trapezoid comes from. It's the fact that it's 2 triangles attached to a rectangle. However we see it, it doesn't matter. You just need to identify the areas here. Okay, so I like trapezoids just because that's less computing that I have to do. So 1/2, my base 1 is length 9, my base 2 is length 5. 5 here, 9 here, and my height is 20. Okay, so times 20, so 20 divided by 2 is 10. 10 times 9 plus 5, that's 14, so that's 140 right there. Okay, so he started at building A. At time 9, he is 140 whatevers away from building A. Okay, then we've got negative areas. So we're going to be going back towards building A. Again, let me do a trapezoid. 1/2 base 1. Let's see here. This one is length from 9 to 15, so that's length 6. Plus from 10 to 14, that's length 4. And my height is, I'm going to include that negative because that's going to help me remember that this is negative area. So that's -5 times 10, so that's -50. Notice they make the numbers really easy to deal with because it's calculator inactive. They're trying to test your knowledge of the concepts here, not your arithmetic. All right, and then last one here, we've got 1/2 times my base 1, 15 to 18 is 3, plus my base 2 is 2, and my height is 10, so that's 5 times 5, so that's 25. So we're at 140 at that time, right here, 140 minus 50 is 90, and then here at the end, we're at 115. So when was it the furthest away? Right there. Now, remember, anytime it asks for farthest is an extreme number. Okay, so farthest, we've got to check endpoints. So we've got 0 and 18. And then we've got those 2 times where it changes direction, 9 and 15. So position at these times, obviously where it starts, it's at 0. We did all the work on the graph, so that's fine. You don't have to like show it here. You can just give the actual values. That table right there can be your justification here. But you do need to say it in words. So the squirrel is farthest from building A at time t equals where? 9, and at a distance of 140. Okay, now the question didn't ask this, but let's just take this a step further and let's think about this. What if it said, when is it the furthest? Well, that wouldn't be much of a question. When is it furthest from building B? Well, duh, when it started at building A. But what if it said, when is it, how about other than when it starts, when is it closest to building A? Okay, other than when it starts, when is it closest to building A? Well, that would be at time 15. Okay, because he goes to 140, then he comes back 50, and then he goes back to 115. So he'd be closest to building A other than his starting point, or other than when he first started. After time 9, he'd be closest to building A at time 15. I was trying to make you think a little bit more. I didn't really think that through before I started asking that question. But all right. So you get 1 point for identifying all your candidates. So don't forget, look for those keywords that say extreme values. Okay, be looking out for those. And remember, you got to include those endpoints. All right, and then your critical points as well. You get 1 point for the answers. You got to have both of them, the time and the distance. All right, part C. Find the total distance the squirrel travels during the time interval from 0 to 18. Well, remember, total distance is absolute value, so that's the integral from 0 to 18 of the absolute value of v of t dt. So that's going to be the 140 plus the 50 plus the 25. Okay, the 50 is no longer negative because that absolute value makes it positive, so that makes it what, 215? You get 1 point. It's 1 pointer right there. We got 4 points left for this last part. Write expressions for the squirrel's acceleration, velocity, and distance from building A that are valid for the time interval between 7 and 10. All right, so let's just look up here. What do we have going on between 7 and 10? Oh, look, they've been nice to us. They picked just a single line segment. Okay, so when I first read that, I was like, oh, we're gonna have to deal with a piecewise function because this is a piecewise function. But they're not asking us for the entire time interval. They're just asking us between 7 and 10. So we're looking at velocity. So they ask us, first of all, for acceleration. Acceleration is the derivative of velocity. Now, do we need to find the equation of that line? Well, you could, but derivative, slope, it's a straight line. So So the slope is equal to the derivative. So let's just find the slope. Okay. So they label it like this. For 7 is less than t, which is less than 10. A of t is equal to y minus y over x minus x. Whoops, 7 minus 10. So that's 30 over negative 3, so it's negative 10. His acceleration over that time interval is negative 10. Now, for velocity, we do need to write the equation in that line. Okay, we do need to write the equation in the line. Well, guess what? We just found the slope. You just found the slope of the line. So to finish it out, y minus, take one of the y values, I'd rather use the positive one, is equal to the slope times x minus the x. And really, they're fine with you doing this. You don't even have to multiply that out. You just need to move the 20 over. Now, if you really want to, you can simplify that, but you don't have to. Oh, why am I using x's? I should be using t right here. Okay, and it probably doesn't hurt to go ahead and simplify it, because then we're going to have to turn around and integrate this. Okay. So what have we found so far? We found acceleration. We found velocity. Now we got to find the distance. I'm going to find the distance. Okay. So we need to start by finding his position at time 7. X of 7. Okay, or S of 7. You better use. I prefer to use S because I'm used to using S for displacement. Okay, so S at time 7, because we got to find out where he started at before we can find the distance formula for that interval there. So if we take off this little triangle, I think it's easier just to find the area of that triangle, right? 1/2 times the base of 1, 2 times the height of 20. So 20 is the area of that triangle right there. So he's at 120, position 120. S of 7 equals 120. So his position at time t is equal to the 120 plus the integral from 7 to, now, we don't want to put 10, because that would give us the position at time 10. We need to put a t right here. And we need to put a t right here. Of our velocity function, so negative 10. Remember, when we have a variable up here, we need to change the variable down here. Okay. Now, it did ask for an equation, so that kind of implies we need to keep going with this. We can't just stop right there. So we need to integrate with respect to u. So it'd be negative 5u squared plus 90u from 7 to t. So that's negative 5t squared plus 90t minus negative 5 times 7 squared plus 90 times 7. Now, I think that we can stop right here, but I know that's kind of a tough place for most of you to leave it. So we need to simplify. So we have 49 times negative 5. So 5 times 9 is 45. 5 times 4 is 20. So that's negative 245 plus 630. So 630 minus 245. Did I miss something up? Nope, I'm subtracting that number. Okay. So we've got 120 plus negative 5t squared plus 90t minus 385. So that's negative 5t squared plus 90t minus 365. Now, personally, This is one where I would get to this part of the problem and I'd say, okay, that's great. I think I know what I need to do, but I'm going to go on to another one of my free response questions and answer it. Nope, not 365, 265. And then come back to this one if I have time, because a little bit of that's a little tedious, and it's just worth 2 points. Okay, why trade those 2 points for 6 or 7 points on another question? Okay, so keep that in back in mind. You get 1 point for the acceleration, 1 point for the velocity, and 2 points for the position because it takes so many pieces.